This is Mr. Hanna and welcome to What the Format. Today I want to go over an actually pretty specific example. I'm solving for x. Now, what I'm going to do with this example is I want to walk you through how I think through a problem, so you can get a better idea of how to apply all these. So in my videos, typically I've handled one concept at a time. Now you've noticed that sometimes you can see some overlap in there, but I haven't really addressed that. Now that you have some concepts down and you're starting to see what algebra is, set of the rules and the notation and the language that's involved. Because remember, algebra is three things, right? It's your vocabulary. That's the words that they use. It's like an English class in that way. Then the notation, the symbols they use. Okay, you have to know what the symbols are telling you. Then it's the process. How do you think through the problem? How do you apply all the things that you've learned? Well, I wanted to go through this example so you can see that. So the first thing I see when I see the solve for x is reverse PEMDAS. Okay, normally that's what solve is. I'm going backwards, reverse PEMDAS. All right, now I can't do that in this case. Why is that? Well, before I solve and start reverse PEMDAS, both sides need to be simplified. A lot of times they'll give you one side that's simplified, but occasionally they'll give you two that aren't simplified. This is not simplified. Either is this. There's math I can do there. Well, what math can I do? Well, let me show you how I think through it. I start with the parentheses, x minus 3. That's what I should do first, because when you simplify, now you're doing a forward PEMDAS. So I'm actually doing, in this problem, both forward and reverse PEMDAS. I can't combine x and 3. Why not? They're not like terms. See, vocabulary term, like terms. What's a like term? The terms have to have the same variable, and those variables have to have the same exponent. This has an x, this doesn't. This has an x, this doesn't. I don't have any like terms in the parentheses. I can't combine either one. So next I go to exponents. Now I know what you're thinking, well, Mr. Hanna, it's obvious there's no exponents there. You're right, no exponents on the parentheses. It is obvious. But if you don't learn to check it and walk yourself through it a step at a time, when it's simple and you can see that, when the problem gets more complicated, those exponents there could mess you up because now you don't know what to do. You're like, wait, that looks different. And I've seen students, when there's an exponent here, they distribute inside there. You can't distribute before you do an exponent. See, we have to go in order. And if you're not used to checking it, and that's the thing with a lot of Algebra 1 students, is they keep it, I don't want to say super simple, but simpler than Algebra 2 level, and you kind of get locked into, oh, this is easy, this problem isn't as bad, and then they start adding steps. And if your brain isn't used to thinking through those steps, then you get lost. So I think parentheses, nope, can't do it. Oop, no exponents. Now I think multiplication and division before the addition. So I'm going to distribute there. 4 times x is 4x. Positive times a negative is a negative. 4 times 3 is 12. And I break it down like that. Why? Because a lot of times they're going to put a negative out here. And then the student misses the negative times a negative, and they don't switch that sign. And one mistake on this is all it takes to get the whole thing wrong. Now I have plus 7x. Okay, now what do? I've got 4x and 7x. That's an example of like terms. 4 plus 7 is 11. I can combine those. And I will do that, just like that. Why? Because when this side's simplified, then I go to the other. Now, if you want to do them together side by side, that's now your choice. This is what I mean by process. There's different ways to go through these and link the steps. You have to find the way that works best for you. You have to find the way that you like to do that gets you the same answer every time, that makes it comfortable. I find it very easy just to do that. Now I come over here. 6 times x is 6x. 6 times minus 9 is minus 54. I'll just bring that down, because once that was a single distribution, this had distribution plus combining like terms. Now, very common problem here. A lot of students now don't know what to do. When you have the x on both sides, we've done our parentheses, we checked for exponents, there wasn't any, we did our multiplication, that was the distributive property. Now we're simplified on both sides, yes? So now what we do is now we're going to start reverse PEMDAS, which means we start with addition and subtraction. I have actually addition subtraction to do twice. I want the x term to be on one side, so there I go, minus 6x. And a lot of students will divide here. Do not do that. Remember, when we solve, we start with addition and subtraction. That will cancel that, okay? Now, I like to do this in the same step. If the variable is going to be over here, okay, remember we want the numbers on the opposite side. So now the opposite of minus 12 is plus 12. What I do to one side, I do to the other. And see, I like to cancel that out. That gets me see my math. I've moved this x term over here with addition, subtraction, not multiplication or division. Don't do divide by 6 there, please. And don't just do minus 6 either. I've seen students do that. You need to add or subtract the whole term, because remember, if you know what x is, 6x is just a single number. And when you move a number over across an equal sign, you use addition or subtraction. You do the opposite. So the inverse of plus 6x is minus 6x. How do I know it's plus 6x? Because there's no minus in there. We don't put a minus in front of a number unless it is a negative, especially if it's in front. Yes? So now, 11x minus 6x. That's combining like terms. We have 5x. Minus 54 plus 12. That should be what? 4 minus 2 is 2. 5 minus 1 is 4. So minus 42. Why am I subtracting here? A negative and a positive, opposite signs. You subtract. So bigger is on top, which is fortunate here. 4 minus 2 is 2. 5 minus 1 is 4. Now, the inverse is divided by 5. And I know the answer looks really ugly, but guess what? It doesn't matter how ugly it looks, because that is the answer. You're done. It doesn't matter that it's a fraction. Now, we could write that as a decimal, okay, minus 8.4. Okay, you could write that as a mixed number. What format do you pick? Well, that depends on the teacher. Some teachers are going to want a mixed number here. I don't like mixed numbers because they're not as applicable, not very applicable once you get past a certain point of math. There are times mixed number here would be good, but it's maybe 10%, 20% of the time. No, when mixed numbers are good. If your teacher asks for it, you want to give the teacher that. Decimals, well, again, that's a format issue. The teacher wants a decimal there, give the teacher a decimal. If they want the improper fraction, which most cases that's what it's going to be, then you just leave it like that. There's nothing else to do. Now, if you're on a standardized test, just look at the answers. The format of the answers will tell you what they want, okay? Hopefully you saw how I thought through this. See, I did my forward PEMDAS first, checking for the exponents, even though I could clearly see there weren't any. It trained my brain not to forget that step. Once I did the multiplication and division, see, this one was done, but this one had my addition subtraction. I added those. Now I did my forward PEMDAS. Once these were simplified, then I went to reverse PEMDAS. And moving variable terms over is addition or subtraction step. And once you know what the variables are, you want to move the numbers to the other side. Now, could I have gone the other way? Yes, you could have subtracted 11x over here. You could have added the 54 over here. And then what would you have gotten? Well, then you would have gotten 42 equals negative 5x. You just would have reversed it. And then when you divide by the negative 5, now you still get negative 42 over 5. Okay, but most students prefer to keep the variable on the left, and that is preferable. I will go against that if this is going to be negative. I don't like to deal with that sign change. Now, I can deal with the sign change, so why don't I? Because it's the number one missed thing in math. And why get as close to the cliff as possible to see how close you can get before you fall off? And that's not safe. Same thing here. If you don't be careful, negatives will get you. Doesn't matter if you've been doing algebra for a day or 25 years or 30 years. Sign changes are the number one missed thing in algebra. So why tempt it? So if I bring this over here and that's going to make this negative, I prefer not to do that. So I'll come over to there. Now, why did I go over there if that was going to be a negative? Well, just to show you that some students may like doing it that way. I'm not going to argue with the student if they prefer that way. I'm just going to point out the possible ways and the consequences of some of them. I prefer the variable on the left as long as it's positive. If it's going to be negative over here, I will often go to the right. Because why? Because you can always flip this. It's called the symmetric property. You can just flip that for free and then circle that. It's basically one little extra step. But again, this is part of the process. How you think through a problem is very important. If you don't practice thinking through this and take your time trying to see what works best for you, okay, and you just copy what your teacher did or what your friend showed you, you're going to run into trouble because you're going to get on a test and your brain's going to be freaking out and you're not going to know how to calm it down. How do you calm your brain down in a problem? You have to think through it one step at a time and not jump ahead and not panic that you don't know the answer. There's a lot of these problems. I had no idea what this answer was when I wrote this out. None. But I didn't panic or worry about it because I knew if I just took it a step at a time, I would get to the answer. Confidence. I built that up. Not in one day. It took me about 2 years for math to algebra to fully click for me. But the difference is from a lot of people today is I didn't give up. I kept at it. I was persistent. And then when it clicked, math took off for me because I realized, oh, it's just the same thing every time. I just have to know the steps. I just have to break it down, and I can do the steps. It's like climbing a set of steps. It doesn't matter if the set of steps is 20 steps or 1,000. I'm just going to climb it one step at a time until I get to the top. And I've trained myself to think that way. So I don't panic when I see a problem that I don't know the answer to, which happens all the time. And I've even had my brain try to panic. I'm like, wait, relax, Mr. Hanna. Don't know the answer, but you know how to take it a step at a time and find the answer. So I just start doing that. And that's a good first step for me, is write the problem down, identify the rule I'm using. That becomes a geometric thinking. Like in geometry, when they give you something, well, okay, they gave me this. There's only a few theorems or postulates that apply to this. I go down the list to see which one makes sense to connect me to the next step, all the way down to the proof. So to me, this makes sense. Okay, I'm gonna do forward PEMDAS. Why? Because these sides weren't simplified. Okay, what if they didn't? What if they gave it to me already simplified, right? What if we gave another example here? Yes? So here's a brand new problem, not that, right? And I'm just gonna say it's 4x minus 3 equals 6x plus 12. Boom, okay? There is no forward PEMDAS here. Why? They're both sides are simplified. But see, now that I'm used to checking it, it doesn't matter whether they're simplified or not. If they're not simplified, I jump into forward PEMDAS. If they are simplified, I can skip that step. Okay, now look, here's an example. See, minus 6x, that's gonna make that negative. I don't like that. Okay, so what do? Minus 4x minus 4x. See, I'm moving the x term over. Now it doesn't matter what number's in front of them or not. I just move them on over. Okay, well, what if this had been negative 4x, Mr. Hanna? Okay, well, then I just do what? Add it. I know how to handle anything they change, and that's what they do. The teachers will show you one thing in class, but then they'll put another thing on the test. You have to know how to handle all the different possibilities. Is there another possibility for there? No, it's either plus or it's minus, right? And then what happens here? See, there's the minus 12. Those cancel. See that? And then I get what? Minus 15 equals 10x. Divide by 10. Divide by 10. Ooh, this now simplifies. I didn't have that with 42 over 5, did I? 5 and 42 had nothing in common, but these have 5 in common. So if I divide this by 5, I get negative 3. Divide that by 5, I get 2. And again, we can just rewrite that for free. Although a lot of teachers will let you circle that because they know it's the same thing. That again, now is up to the teacher and your preference. Most students would prefer this, so go ahead and just rewrite it. Took me what, 5 seconds? And now you can see I can handle it when I need to simplify it and when I don't. When it's a minus, I know how to get it over, and notice I went to this side. Now I could have done the minus 6x, yes, but notice that would have given me a what? Minus 10x equals 15. So I'm still getting the same answer, yes, but see, I got a sign change there. Now you might argue and say, wait a minute, Mr. Hanna, I had a sign change there. Yes, I did. So really, me going this way or this way in this particular case didn't affect the problem, but there are times that going one way or the other, you'll create a sign change and the other way there won't be. But see, that way, if you're noticing that, see, you're starting to think for yourself. You're starting to actually see what's happening, which is what the goal is. So then you can make your own decision. And you say, I like going this way. Okay, go that way. See, there's still your negative 3 halves, and then you didn't have to rewrite it, did you? And now, all of a sudden, who's in control of the problem? You. I've shown you what I do, and you're like, wait, Mr. Hanna, that doesn't work for me. I want to do it this way. Now you're getting it. When you reach that point where you can do the problem differently than me, but still get the same answer and you know you're right, that's when you're now in control of the problem. And the problem is not controlling you. And that's what you need to do, especially when you get into standardized test territory, ACT, SAT, and the myriad of other end of course exams that they're putting all throughout school districts everywhere. They will test you on these little things to see if you know what you're doing. And it only takes one thing to be off to get in trouble. This is why we practice. This is why we think through the problems. So here's an example of me thinking through a problem that's very common. 2 types of problems are very common with the variables on opposite sides. One where you had to simplify first, the other where you didn't. And there's an infinite number of kinds of combinations of these. So at this point, if you're starting to get it, this is where if you did 30 or 40 practice of these and really solidified what you know, now you're getting it. Unfortunately, as I'm well versed in students' habits, yeah, they won't do it. But here's the thing is, if you don't practice the right way, if you don't put time into something, you're never going to get good at it. I'm sure your coaches said the same thing if you're in a sport. If you don't practice the sport outside of practice and do stuff on your own, you're never going to really, you're going to tap out. You're never going to get to the level that others get to and maybe that you thought you wanted to get to. Why do I say I think you want to get to? If you're not willing to put the time and work in there, you don't really want to get to that level. Because at this point, to get to a championship level requires a certain amount of work and effort. And if you don't put in the work and effort, you just don't get there. It's just not happening. Yes, there are some rare talented people that their talent just keeps them going to a really high level. But even then, even with your talent, I've seen that with math students, at some point your talent runs out. You have to be able to think through problems. You have to be able to have that ability to put the time and the work in. And those that do can, sky's the limit. But most others, we limit ourselves because we just don't want to do the work. Think through the problems. Here's how it works. This is how you solve algebra problems. Hopefully this has been very helpful, that you can see seen my thought process. Go back over it, watch how I went through forward PEMDAS, watch how I went through backwards PEMDAS, how I noticed the difference. Rewind it, think for yourself, try some other problems, see if you can duplicate that thought processes, and then create your own that's unique to you, that works for you. Okay, start with what I do and then modify it to fit you. That's what I did with my teachers. And that's how I got better at algebra and better at algebra. And eventually, now I can solve all sorts of these problems. And it doesn't matter how many of these there are. I could have had distributive property 10 times in here. Really long problem across the line. Doesn't bother me. I just do it one at a time, start combining like terms, and eventually I get there. Now, what if I made this a 7x squared? Think about that. Now all of a sudden it's going to be a quadratic, isn't it? And now I'm going to need, instead of having the x's on one side, the numbers on the other, and I need everything on one side, because that's how you solve a quadratic. See, you have to be able to adjust when they throw a little wrinkle in there. And putting a squared there is one little wrinkle. Hopefully I'm getting your brain to start thinking at this point. Your brain's going, whoa, wait a minute, that's a lot, Mr. Hanna. Exactly. There's a lot there. That's why you have to practice. That's why you have to learn to think through it, so that you can handle all these little variations and differences, because that's what life does. And if you get good at solving algebra problems, now you can start solving life problems. It's a life skill that you're learning when you solve algebra problems. That's what I've discovered. If I take my real world problems and I break them down a step at a time and do them a step at a time, they're not nearly as big or daunting as they seem to be. Hopefully this has helped. Thank you for watching What the Format. This is Mr. Hanna. Happy mathing.